Light. Ever wondered what light is? And what is its effect on our lives? Through this and some upcoming videos, we will try to find out answers to the similar questions. Let's take an example. We are able to see a whole lot of things in the world around us, but we are unable to see things placed in a dark room, right? Why does this happen? Exactly. The answer is light. During the daytime, light rays from the sun get reflected when they fall on objects. This reflected light rays on entering our eyes enable us see these objects. Image formation by mirrors, twinkling of the stars, various shining phases of the moon, appearance of rainbow after the rain. All these are possible due to light only. Without light, we won't be able to see any of these phenomena. We have already read in our 7th and 8th grade about the nature of light and how light rays travel and form images on plane mirrors.
Let's recall the laws of reflection.
Number 1. The angle of incidence is always equal to the angle of reflection. Number 2. The incident ray, the normal to the mirror at the point of incidence, and the reflected ray all lie in the same plane. Along with that, we are also familiar with the properties of the image formed by plane mirrors. Number 1. The image formed by the plane mirror is always virtual and erect. Number 2. The size of the image formed is always equal to the size of the object. Number 3. The image formed is as far behind the mirror as the object in front of it. Number 4. The image formed is laterally inverted. If the plane mirror is replaced by the spherical mirror, will the characteristics of the image change? Let us try to understand the spherical mirror through this activity. My name is Rahul, and today I will learn about image formation with the help of this shiny spoon. Hey, as I am taking the spoon away, the size of my image is getting smaller. What? Why is my image inverted in the spoon? What if I turn the spoon over? Here also the size of the image is getting smaller, but it is erect, not inverted as it was in the first case. Could you think why this would have happened to Rahul? The shape of the spoon is spherical, not plane. Those mirrors which have spherical reflecting surfaces like the spoon, in this case, are called spherical mirrors. The small and inverted appearance of the image are two of the characteristics of the image formed by spherical mirrors. Why are they called spherical mirrors? Let us understand why. Take a large sphere and cut it in such a way that we get spherical arc-like shapes. These shapes can be polished in either of the ways to make a mirror. If the reflecting surface of the mirror is tilted inwards and towards the center of the sphere, then it is called a concave mirror. And the mirror whose reflecting surface is tilted outwards is called a convex mirror. Let us try to understand the spherical mirror with another activity. Hello friends, I came again. Now I will show you something with the help of a magical activity. A concave mirror and a paper would be needed to perform it. I will place the concave mirror in such a way that the rays of the sun after getting reflected by it directly falls on the paper. I will keep on doing this process while moving the paper back and forth until a sharp point of light is made on the paper. After some time, we could see the paper smoldering and the smoke coming out of it. Why would this have happened? This is because the concave mirror focused the light coming from the sun in one place. And in science, this point is known as focus of the concave mirror. Another interesting fact about spherical mirrors is that in the case of concave mirrors, the focus lies in front of the mirror, while in the case of convex mirrors, the focus lies behind the mirror. As we know, that a spherical mirror is the part of a sphere and every sphere has a center. This center is known as the center of curvature of that spherical mirror. If a line is drawn from the center of curvature and focused to the mirror, it will always pass through the center point of the mirror, which is known as pole. This line is called the principal axis. and the distance from the center of curvature to the pole is called radius of curvature. The distance between the focus and the pole is known as focal length, and the circular distance is called aperture. One should keep in mind that radius of curvature is twice the focal length. Like focus, all these points lie in front of the concave mirror and at the back of the convex mirror. Let's move forward. We have already discussed the spherical mirror and its terminology. Today we will discuss representation of images formed by mirrors and the cases of convex mirrors. You must be familiar with some of these pictures cited from your book, where image formation is shown with the help of ray diagrams. To understand these diagrams, we have to remember the rule of 2 plus 4, where 2 is the number of rays and 4 is the number of cases. To make any ray diagram, we need 2 rays of light, which could be taken from any of these 4 cases. Case 1. If the ray of light travels parallel to the principal axis, after reflection, it will pass through the focus of the concave mirror or appears to diverge from focus of the convex mirror. Case 2. If the ray of light passes through the focus of the concave mirror or appears to move towards the focus of the convex mirror, it will emerge parallel to the principal axis after reflection. Case 3. If the ray of light passes through the center of curvature of the concave mirror or appears to go towards the center of the curvature of the convex mirror, it will travel back from the same path after reflection. Case 4. If the ray of light falls obliquely to the principal axis towards the pole, then it will be reflected back obliquely, making an equal angle to the principal axis. Now Rahul will show you an activity for how the image is formed by a convex mirror. To understand the image formation by convex mirror, a convex mirror and a pencil will be required. Hold the mirror like this in one hand and place the pencil in front of the mirror in the other hand. Now look carefully in the mirror. We will see a small and erect image, and as the pencil continues to move closer towards the pole, the image appears to move towards the pole from the focus. But the size remains small, so it can be concluded that a convex mirror always makes a diminished and erect image. If we talk about the ray diagrams, then only 2 cases can be possible for convex mirror. Case 1. Position of the object at infinity. If the object is placed at infinity, the rays will travel parallel to the principal axis, then get diverged on falling to the mirror, and the image appears to be formed behind the mirror. The size of the image formed is very small and its nature is virtual and erect. Case 2. In the second case, the position of the object will be in between the infinity and the pole. In this case as well, the rays of light will be diverged after reflection. But from the rule of 2 plus 4, the image appears to be formed behind the mirror between the pole and the focus. Here too, the image is smaller in size than the object and virtual and erect in nature.
Convex mirrors are used as rear view mirrors in cars, buses, etc. as they form diminished and erect images.
So through this video, we were able to know what reflection is and how the spherical mirror reflects. We have seen the reflection through a convex mirror. In the upcoming video, we will learn how reflections takes place in case of concave mirrors.